Welcome to the Wind Sustainability series. This is episode number 9, Single Engine Taxi In. In this video, we are going to talk about what you can do as a pilot to reduce aircraft emissions thanks to single engine taxi in. For example, on the A330-200, this saves approximately 31 kilograms of CO2 per minute. Single engine taxi procedure for twin engine aircraft or two engine taxi procedure for four engine aircraft is available in the FCOM for all Airbus aircraft types. Airbus highly recommends single engine taxi in when conditions permit at arrival. We observe that single engine taxi in is now pretty much widespread. However, as a pilot, it's important to be aware of the associated threats. This is why I would like to highlight the importance of threat and error management. A usual threat is the increased thrust because only one engine is running. There is a risk of jet blast and foreign object damage. In line with the competency-based training and assessment and evidence-based training concepts, the pilot competencies are powerful barriers to manage threats and errors. Let's start with communication. The flight crew should discuss when and where they will shut down the engine. The objective is to share in advance the action plan. Communication and coordination are required in order to avoid any startle effect when one crew member shuts down the engine. Communication with cabin crew may be required, for example, if electrical load shedding is expected. Single engine taxi without APU may affect galleys or IFE depending on the configuration of the aircraft. If the aircraft stops in a congested area, communication with ATC may be necessary before increasing thrust in order to ensure that no ground personnel is around the aircraft. Finally, communication and coordination with ground personnel are important, especially if the APU is not used, because the external power is connected while one engine is still running. Now, in terms of knowledge. Understand the effects of single-engine taxi with or without APU. Understand the importance of cooldown time for the thermal stabilization of the engines. Then, be aware that the procedure associated with single-engine taxi may change between aircraft configurations. Knowledge about the airport includes the gate, ramp, and taxi route. Some uphill slopes, sharp turns, or congested ramps may prevent single-engine taxi or make it more difficult. In addition, you should know the restrictions that may apply at specific airports as published in the applicable charts. Finally, you should be aware of the airport infrastructure, such as the available support at the arrival gate, particularly in the case of single-engine taxi in without APU. Maintaining situational awareness during single-engine taxi is very important. At any time, be aware of the level of thrust, the position and direction of your aircraft, and its technical status. Be aware of your surroundings, ground personnel, other aircraft, etc. If installed, the airport moving map, ADS-B or taxi cameras can be helpful, as well as listening to the ATC frequency. Be aware of the weather conditions. Slippery surfaces may prevent single-engine taxi in. Time. Be aware when the engine must be shut down in order to respect the cool-down time. Be aware that time pressure increases the risk of errors, especially if performing several tasks at the same time. Let's focus now on workload management. Workload is usually less of a problem in single-engine taxi-in compared with taxi-out. However, the flight crew must remain vigilant, especially at the end of the flight and given the risk of fatigue. As for single-engine taxi-out, plan and anticipate tasks. For example, if the APU is necessary during taxi, anticipate the time required to start the APU so that it's available when the cooldown time has elapsed. Prioritize tasks in an appropriate way and delegate when necessary. Problem solving and decision making. Check the available sources of information in order to decide if a single-engine taxi is possible. For example, airport charts, meteorological information, ATIS, ATC. Keep in mind that the decision to perform a single-engine taxi should be compatible with the status of the aircraft. At any time, if the flight crew considers it necessary, they can decide to start the other engine. To conclude, we saw what are the essential competencies for single-engine taxi-in. Keep in mind that single-engine taxi reduces CO2 emissions during the taxi phase. The CO2 savings may appear small from an individual flight perspective, but fleet-wide, single-engine taxi definitely makes sense. That's all for today. Thank you for watching this last episode of the Wind Sustainability series.